Hi everyone, I just wanted to show you how to graph a helix, since this was a question that's come up a couple times today, real quickly. And the question is mostly concerning the orientation and how does the helix actually look. So for example, the one that I've got right here, this is our RT, and it's got a 3 sine t and a 4t and a 3 cosine t. Now the way that we determine the order, the way that the helix is going to be organized is by looking at the sine and the cosine parts. In this case, the x, which is the sine part, and the z, which is the cosine part, means that we're going to have a circle in the xz plane, and then that circle will form a cylinder because the y variable is left out of that equation. So what I mean by that is if I just write it, x squared plus z squared, that would be equal to, in this case, 3 sine t squared plus 3 cosine t squared, which is 9 sine squared t plus 9 cosine squared t, which is equal to 9, because sine squared plus cosine squared is 1. So that means that we have a circle in the xz plane, and the radius is equal to 3. So in the xz plane, so here's x, here's z, here's y, but that's not quite there yet. So in the xz plane, we have a radius of 3, so 3 units in each of x and z. So if I try to draw that, looks something like this. Something like that. But the y variable is free. So if I switch colors here, the y variable right there, that's y. Y is left out of that equation. Because there's no y, it means that we're going to have this same circle no matter what the value of y is. So it's going to look something like this. And that's the orientation of our cylinder. Now, we also talked about where it starts. Where does the graph start? If we type in r of, say, 0, that's our initial point. In this case, the x component would be 3 sine of 0, which is 0. The y component is 4 sine of 0, which is 0. And the z component is equal to 3 cosine of 0, which is 3. So it's going to be beginning, in this case, at the point 0, 0, 3, which is right here. And then we have to figure out which way it's going around the cylinder. So the easiest way that I can think to do it is to use the tangent vector to see which way you're moving. So if I do r prime of t, that would be equal to 3 cosine t, 4, and negative 3 sine t. And r prime of 0 will give us the direction of motion. That's what the velocity vector gives you. So it's 3, because cosine of 0 is 1, then 4, and then 0. Now if I tried to show what that vector does, it has a positive x component and a positive y component and 0 z component. So it's really not moving up or down at all because this z component is 0. But it is moving in the x direction positively, in the y direction positively, which means that it's coming out this way and wrapping around, and then coming back around the back side of the cylinder, and then doing the same thing. Doing the same thing, and it just keeps on going. So the only thing that I have left out of this is the scale. If I were to put the scale on here, we need another color. Let's go with purple. All right, so because the period of the sine of t and the cosine of t is equal to 2 pi, then that tells us that one complete loop around the circle is 2 pi. So starting from right here, that's t equals 0. When we return to that point, that's t equals 2 pi. That's t equals 4 pi. Okay, well, if that's when t is equal to 2 pi when we return, then we can see what the y value is. when t is equal to 2 pi, little t equals 2 pi, the y value is equal to 4 times 2 pi, which is equal to 8 pi. So this point right down here on the y-axis is 8 pi. So we've gone from 0 to 8 pi in one complete cycle. Now, when you get to this point, that would then necessarily be 16 pi. Okay, so now I've got two quick examples to make sure we get the orientation of the helix and the direction of motion. The first example, I've got the x component is the linear part, which means it's going to be traveling around the x-axis. It's going to go in a cylinder parallel to the x-axis. You can also see that by looking at the fact that the y and the z components are the sine and the cosine. So the y squared plus the z squared terms, 4 cosine t quantity squared plus 4 sine t quantity squared will be equal to 16. It would be 16 cosine squared plus 16 sine squared, which is 16. So in the yz plane, we have a radius of 4. So in the yz plane, that's kind of like the wall that I'm usually drawing in class. So we draw a circle with radius 4. So you have to use your imagination that that's the radius of 4. And then because the x component is the linear component, it's going to be this circle dragged out for every single possible value for x. That's what makes it a cylinder. And it looks like that. Now, to get the orientation, if we plotted x equals, or t equals 0, we'd have x is 0, y is 4, and z is 0. And if we look at the derivative, r prime, that would be equal to 2 negative 4 sine t and positive 4 cosine t. And r prime of 0 will give us the direction of motion, which is 2, 0, positive 4. So from this point, the x component is moving in the positive direction, and the z component is moving in the positive direction. So it's going to go up and around, something like that. Something like that, although this part doesn't look right. There we go. Something like that. And then it goes around. Okay, now the second example, we have the x component and the y component are the sine and cosine part. So x squared plus y squared equals 64 in this case, which is a circle of radius 8. And I can draw that here in the xy plane. And the z component is the linear part, so it's going to go up parallel to the z-axis, something like that. And then the derivative, r prime of t, would be equal to negative 8 cosine t, negative 8 sine t, and a positive 3. Okay. So to graph that, if you plugged in 0, the x component would be negative, the y component would be 0, and the z component would be positive. We would be starting at the point, I didn't say this, r of 0 would be equal to 0, 8, and 0. So x is 0, y is 8, z is 0. It starts right there, and then the x component goes negative. So it goes around the back of the cylinder, comes back to the front, around the back, and back to the front, something like that, and wraps around. Okay, I hope this was helpful. Let me know if it was. Thanks. Bye.